Thanks everybody for coming. I just wanted to say, really appreciate all the work the conference conference organizers have done. This is not an easy feat to pull off, and it's run so smoothly, so it's really great. So hi everyone, I am Luke Lee, and we're going to talk about linting today. So first off, just like get the boring stuff out of the way, a little bit about me. As mentioned, I work at Octopus Energy, fighting climate change and trying to keep the world around. And I work on a product called Kraken. So you'll definitely notice a lot of octopus memorabilia and stuff. And then we'll kind of go into a little bit about what Kraken is a little bit. And just like a bit of trivia, I'm also a yoga teacher. It took me a long time to get that certification, so I like to mention it whenever I can. And I'll, if anybody wants to talk about yoga or Python afterwards, I will definitely be around. So the topic of the day is linting. Like first off, we should probably discuss like what is a linter. Wikipedia says that it's analyzes code to flag errors, bugs, stylistic errors, and suspicious constructs. That's a whole lot of words, probably too many words for a slide, and it's a little confusing. So I think it's really broad, and that's kind of important because a lot of the tools I'm going to talk about today cover all sorts of different things, not only like style problems or trying to find bugs or errors. A lot of different things can be a linter. So this broad definition is actually kind of nice, but if you want to simplify it, I kind of think of a linter as kind of like three different roles. First off, it can be like a critic. So it can complain about your code or like maybe even your comments or your commit messages. I mean, it can kind of complain about anything along the software pipeline. It can also be a teacher. So sometimes you can set some of these tools up, not only to complain about what's going on, but also to kind of like give you hints and maybe talk to you about, or like give you examples or other ways to do different things. So it can like teach you maybe better practices. And then finally, you can also think of it as kind of a janitor. So you can kind of make a bit of a mess. Maybe you don't format your code the way like you want to, or you can change different things. And then you can have these linting tools come behind you and actually clean it up and maybe even like change the code or like reformat and different stuff like that. So that's one way like to think of a linter is like performing these different three roles. So next, why do we even need linters? Well, first off, we're all humans and humans make mistakes. To me, that's kind of like a defining feature of a human is that we make mistakes. So we're going to always have bugs in our code. How can we like build tools and practices and stuff to prevent that? Next, to codify best practices. So I've been writing Python for probably 12 or 13 years now, and I kind of have an idea of like what makes Python good code or like good Python code and what makes bad Python, mostly because I've done it wrong so many different times that I have like an idea of like what not to do. So if you use these linters, you can sometimes codify a lot of that like experience that you have. So like some of the people on our team have been developing Python even longer than me, and they've like learned the hard way about a lot of different like practices and patterns that you should use or not use. So you can codify those into these linters and kind of like, again, the whole teacher role for a linter. Next is consistency. So it's easier to look at code like when it all looks the same, right? And we don't typically have this problem too much in the Python ecosystem because the indentation and just like the community has really embraced like a specific style and aesthetics. But it's still important to like have consistency in a code base because when you open up a file, it's easier to read if everything kind of looks the same or flows the same way. So you can also use these linters to enforce some consistency so that your code looks the same. Also, another like hidden benefit that maybe a lot of people don't think about when using for using linters is faster code reviews. The reasoning there is that if you've ever been in a code review and people are complaining about like, oh, well, did you put a line break here? Oh, you should have 2 blank lines here. Or you should wrap the code based on a parenthesis here or there. And that can like really kind of send the whole PR review into like a completely different conversation and you arguing about all these little bitty things. And then you miss like actually looking at the logic or finding out what the real problem is. So if you use a lot of these linting tools, you can just have them do all that stuff for you and like format the code so that your code reviews aren't like, you're not wasting human time on something a computer can do. Finally, the other reason for like having linters is that I think it's easier to have criticism come from like a computer as opposed to like a person. So if I was in like your PR review and I complained about like the way you did something, you might, sometimes that can be like there's some animosity in there or can make someone feel like they didn't do a good job or like they should be doing better or like that human interaction can sometimes be really tricky, especially for junior developers. So I find that if you have the computer complain about these things, it's a little easier for everybody to like take. And then there's not that like human animosity that can potentially come into play. So the computer just complains and you think, okay, well, it's just a computer, it doesn't matter. I can like fix the problem. It's not a big deal. So if you're contrarian like me, you might still ask, okay, well, those are like pretty good reasons, but really why? Like, why do we need linters? So enter the project that I work on primarily at Octopus Energy. It's called Kraken. And this image here is like our like logo for the project, but it's also pretty apt because it has 8 tentacles, and our Kraken definitely has that. So Kraken is like a giant Django monolithic application. It supports millions of customers all across the world. It is deployed in at least 9 different countries. So what we do at Octopus is we try to provide green energy to the world, and we can charge your electric vehicle. We're doing lots of research into like heat pumps and all of that stuff. We can control your thermostat, charge your Tesla, provide electricity to different people all across the world. So that's what Kraken, and Kraken actually does all of this stuff. So inside of this Django application, we can like manage how much energy you use, electricity that you use across different, like 9 different countries, at least at the moment. Last time I checked, it was 9, but it's rapidly growing. So as you can imagine, this is like a really, really big application. We have hundreds of developers around the world. So anytime I always joke with people that start, like the first time in the morning when you do a Git pull, it's not uncommon to see like a couple of hundred commits come in. I think we just crossed 50,000 PRs that we've merged since the project has been around, maybe 5 or 6 years. And also this Django application has over 1 million lines of our own Python code. That's not counting any of the dependencies or anything. So as you can imagine, this is a massive, massive project. So we need all these linters and tools built in to try to help people so that when you're developing something, maybe you don't push something that takes down Kraken across like 9 different countries or in your own region or something. So we need a lot of these guardrails to kind of help people like follow the best practices and kind of the guidelines that we have for like setting up Kraken. And if you work on a code base that has over 1 million lines of Python, you might feel like one of these. There's varying levels of like frustration, elation, maybe you're feeling like sick, or you just feel like you've been beaten up because it's just such a massive, massive project and it takes a lot of time to get your head around everything. So a lot of these linting tools can like help you get there faster. And so that you have a little bit of confidence when you do a push or a deploy that you've done all the checking you can locally and even in your CI environment to make sure that you have some reasonable certainty that your code is going to actually work. The other thing to point out about all these linting tools that I'm going to talk about is this is not just a Python concept. Every ecosystem or language has its own linting tools. This linting is not like a Python thing. It's more important, I think, in Python than other languages because Python's interpreted. So a lot of these linting tools are more necessary than because you don't have like a traditional compiler setup. So all that's to say is that all the tools I'm going to talk about are Python related tools, but that's not anywhere near like all the types of linting tools that are available in like software development in general. So just a quick overview of like what tools we're going to talk about that we use on Kraken. So a lot of this stuff is very specific to like the way we use these tools inside of our Django project. So the first of which is Black. Black calls itself the uncompromising code formatter. It comes like Black has been around for several years, and it was kind of started and known for the fact that it had very little configuration options. And that was actually by design. So the idea was that if you don't have a whole lot of configuration options, you don't have a bunch of people sitting in a room complaining about style. So before Black and before a lot of these style like checkers came out, it wasn't uncommon for me to be on a project. When we would start the project, you get into a room and everyone would decide on the style guide so that you could start the project, and then everybody writes code that looks consistent and follows the same style. And that meeting tend to take days and could be, people could get really upset. Like we're all, I think, especially Python developers, we're like really tuned to the aesthetics of the way the code looks. So you can end up in this conversation where you're having to complain about like, oh, I actually think that we should wrap at 99 characters or at 79 characters, or all these like conversations can take forever. But what black does is it takes all that configuration out and you just used black. Now, as black's matured, it does have a bit more configuration options available, but typically we, like at Octopus, tend to use it mostly just out of the box. And I like to always tell people that the interesting thing about black is that its style guide kind of makes everybody a little bit upset or a little bit annoyed. I don't know that anybody really loves everything about it. Like for me, particularly, there's certain things that I just don't like. I really don't like double quotes. I tend to like single quotes, but the black default style, I think, is double quotes. So there's just certain things that like everybody will kind of dislike about it. But the important thing is that everybody is using the same thing. The best way to really understand black, though, is to kind of see what it looks like or what it does. The actual code is not super like important at the moment, but if you look at this, it's pretty hard to read. I specifically like wrapped it in weird ways. Like you probably wouldn't accidentally like write your Python code this way in general. But the cool thing is that like you could, if you really like it to look this way, the way I do it and the way most of the people on our team do it is I have black configured in my editor. So I can type all the single quotes that I want. And then when I save it, it reformats the code and then adds the double quotes and makes it look like the black version. So if you fed this code into black with like mostly default options, you'd get something out that looks like this. Notice everything is like wrapped nicely. We got a little bit of white space in there, so everything's a little easier to read. We switched to double quotes, but again, that's useful for me because I'm typing single quotes in my editor and then getting double quotes out. So again, just like another look, all the code is like squished together, pretty difficult to read. Black can reformat for you. And here's just like a couple of the options that we tend to use on inside of Kraken. It took me a long time to kind of get used to the idea that code could be longer than 79 characters. I'm very much like an old like sit-in Vim Unix guy that likes his like little terminal. But when you work on a project as big as Kraken, sometimes just your imports, there's so many sub packages inside of Kraken, just your imports can be really, really long. So having like 99 characters is useful. And then we're like a global organization, so we don't do any like underscore normalization on numbers and stuff like that. But in general, that's pretty much all the configuration we have in black. The way we use black is like the -- check option. This is really important. So what black does when you give it the -- check is you feed it a file, and then it will just tell you if it would have reformatted the file, it will return failure. And if it didn't, it will return success. So it's a nice like Unix tool that plays really well from the command line. So that works like really easily in your CI. So you can just fail the build if black was going to change your code. The other important like thing to note is that we don't, like as part of the build or something, have black actually edit the code, because we want Git to track all the code. And when we do a deploy, we want that to know that that exact SHA and that exact code was deployed, not some like code that was checked out and then ran black on it and then maybe it was reformatted or something like that. So on Kraken, it is like the developer's responsibility to format the code with black. Again, most people just hook that up into your editor, and when you save, it runs black on the file, it reformats it. You basically don't ever think about it. But as part of our build, as we'll see later, we do the -- check option to just verify that everything was run with black. The other cool thing about black that is not often mentioned, but I think is probably the most interesting thing about how black works, is by default, it runs with this option called -- save or -- safe. And what that really does is black works at like the lower level, like it looks at the actual AST. So it will, the abstract syntax tree. So black will take the code that you gave it and will look at the AST, and then it will reformat the code and look at the AST and verify that it didn't actually change any of the semantics of your code. So it's just strictly formatting. I don't know many other linters that do this. Maybe a lot of them do and they just don't talk about it, but I just think that was a really cool option. And again, that's on by default. You can turn it off because it'll make black run a little bit faster, but in general, I think it's a great thing to have. So now that we have like our code mostly formatted correctly, it's worth noting that you can have black format your imports as well, but we use another tool called ISORT. ISORT, you know, their tagline is kind of cute. It's ISORT your imports so you don't have to. This is really nice because, again, on a project as large as Kraken, you have lots and lots of imports. And it's nice to be able to navigate those in like an consistent way and kind of be able to easily find something. So the main thing that ISORT does is it will, by default, organize your imports based on alphabetical order. So it's easier to find something when you're just jumping around. And again, kind of like Black, ISORT is easiest to see what it does by looking at like an example. So here's some imports that I took directly from Kraken. We have all these different things. We're importing Django. Octo Energy is our package, so that's Kraken. We're importing some typing and then all sorts of different stuff inside of Kraken. So this isn't too bad. It's pretty easy to follow. Like some of the problems are like, if I want to find a particular import in this, I kind of have to read from top to bottom. I have to look through all of them. Also, you might end up like someone might like move a import around, and then maybe you have like one commit that all it did was like take an import from line 1 to line 3 or something, and then you just have a bunch of extra like commits that maybe you don't need, diffs that you have to look through when you're bug hunting and that sort of thing. So if you feed this particular code to ISORT, you get this code back out. So notice it did a couple of different things. First off, it organized everything by alphabetized them, and then also broke it up into different chunks. So at the top, you see like the standard library imports. Then you see kind of like your third-party imports like Django and stuff, blank line, and then you get all of your like local imports. So this makes it easier to navigate. If I'm looking for an import and I know it's a Kraken import itself, then I can like immediately jump to that third section and start looking. And also it's easier to find things because it's alphabetized. So I don't know about like anybody else. I mean, I really, like I said before, Black, the formatting, I like love and hate some of it, but I really, really love ISORT. And for some reason, like whenever I like feed it imports that look like this, and then it comes out looking like that, I don't know, that just makes me like unreasonably happy for some strange reason. I really love the cleanliness of how like ISORT does that stuff. And just so like a couple of different options that we use in ISORT. ISORT is very different than Black in that it has lots and lots of configuration options. Cool things are you can control how you want it to wrap multiple lines. So here we're saying multi-line output is 3. I think that turns on the hanging indent. The other nice thing is that you can tell ISORT what is a first party package or what's a third party package, so that like we use like different packages that maybe are not on MyPy or on like on our own internal MyPy. So ISORT doesn't know whether that's like a built-in import. Well, it does know if it's a built-in import, but it doesn't know if it's like a first or a third party kind of thing or something that we developed or something else. So you can control all those options so that the imports will get put into the section that you want. And then again, we tell the line length and stuff. So how we use ISORT is very similar to the way we would use Black. So instead of -- check, ISORT calls it check only. And what that does is you feed it a file and ISORT will tell you, would I have reformatted those imports or would I not? And that will return success or failure. So again, you can hook it into the build just like that. So that's really nice to be able to run on your CI and sort of things like that. Okay, so now like moving a little bit away from just formatting. So we have Black that formats our code. We have ISORT that is really only focused on sorting and like formatting the imports. Next, we have a tool called Flake 8. I think Flake 8 really undersells itself. So it says it's a tool for style guide enforcement. That's definitely true, but I think it can do way more stuff than that. Like as we'll see later, it's not just for style necessarily. So again, like all these tools, one way to see what Flake 8 does is by seeing an example. So Flake 8 is what I would call like a static analyzer. And the idea is it's kind of analogous if you're like an old C programmer like me to kind of like a compiler, but it's not going to actually do any compilation or turn your code, like take your code from Python into machine code or anything like that. But if you are used to like a compiler environment, you would write some code, you would compile it, and the compiler would complain at you and saying like, you didn't declare a type, or you have a typo in this variable name, or like various different things that the compiler would complain about. And that was pretty nice because then by the time your code was actually compiled, you had at least a little bit more certainty that your code probably worked or like didn't have any like very like glaring obvious problems. And in the Python community, since Python's interpreted, we don't necessarily have that because Python all happens at runtime. It's interpreted. So if you have an error, you don't see that error until that particular line of code is executed. So here's where Flake 8 can kind of come in. So you can run Flake 8 on your code and it can like warn you of common problems that you might have or like errors or anything like that. So here's just like some silly code that I wrote for an example of like what I would do on a weekday. So if you run this code, it will check the day of like what day you're running it on. If it's a weekday, it will plan the week on the things that I do. So pretty much Monday through Friday. I'm fighting climate change, doing yoga, and walking my dog. Those are kind of the main things that I do during the week. And then on a weekend, I try to just relax. So the problem is here, if I ran this code on a weekend, it would always work because the planned weekend function has no typos, but it's pretty hard to see, especially on a slide maybe. But this get to-do list function actually is missing an S. So the join line says to do, not to do's. So I won't necessarily ever see this problem unless I run this code on a weekday. So that gets to be really annoying because if you deploy the code, if this was like a more real life scenario, like your code doesn't always work. It maybe depends on a particular day. This is like the worst kind of bug to have. It's like it only fails on certain days of the week or something. So what I could do is I could feed this code to Flake 8 as instead of just deploying it and like not doing anything with it. And Flake 8 will tell me stuff like undefined name to do. So it's basically telling you would have had a name error on line 5 if I ran this code. So that's really useful to hook up to your CI because then you can write your code, you can run it through Flake 8, and Flake 8 it's not going to find all the problems. It's not going to find like actual logic problems that you have, but it can find a lot of stuff that you might just have easily missed. The other cool thing is you can hook Flake 8 up to like pretty much whatever editor you have, and it can give you like those little squiggly lines or kind of like give you like error lines and that sort of thing, so that even when you're writing the code, Flake 8 can be running and tell you even before you even explicitly run Flake 8 as part of the build. But this is where I was mentioning that I think Flake 8 really undersells itself because it comes with a whole bunch of checks built in. So like that name error, all of those sort of things are like built into Flake 8, and it does a lot of different like checks by default. But there's a robust configuration like to customize Flake 8 and build your own linters and your own checkers. I think is the terminology that they use is maybe checkers inside. And the other cool thing is that you can build all this with Python code. So you can use Flake 8 as kind of like a framework for building more like linters of your own. So you can enforce like your own like style guides, or you can enforce like different practices. We have quite a lot of Flake 8, like custom Flake 8 stuff in Kraken to do all sorts of things. Like we verify that you're like using our own logging module as opposed to like the built-in logging module for like various reasons that aren't super interesting or relevant to the talk. We have Flake 8 linters that run to verify that you have like tests or all sorts of different like options that we've like built our own. So like, how would you do that? So this is a very simplified version. There's a couple of different ways you can do it. Usually I find like when you're writing these custom linters using Flake 8, the hardest part is actually getting it installed and getting like the configuration right, not necessarily writing the linter itself. But I'm going to skip the whole, we just don't have time to talk about like how to do the configuration and like make it set up. The documentation in Flake 8 is really good for that. But here's how we would like maybe write a linter. This is actually one that we do have inside of Kraken. So we don't want any code to ever be checked in using the print function because we're a Django application. Like where would that print go? Does it go to standard out? Does it go standard error? Is that even useful in like a web application to just print to the screen? Probably not. So we just don't want any code to ever be checked in that has the print function being used. So we wrote, this is a simplified version of the one that we have. We can create a class, and then Flake 8's like API provides that it's going to give you the whole abstract syntax tree. So if you want to do some really sophisticated stuff, you can look at the AST of a particular file, and like maybe you would want to enforce that you don't ever use the continue keyword or something. I don't know, like that maybe not a great example, but you can look like lower level at the code and see what it's doing and kind of turn on and off or like disallow things. So it'll give you the abstract syntax tree, the name of the file, and then just a list of all the lines. So if we wanted to like build this class, then you implement like a run method. And in this case, we just want to make sure that like no lines have the word print in or like the print function in them. So we just implement a run method, and then it makes you yield out these different things. So like you have to return the line number the problem happened on, the column number, an error message, and like the type of linter that was run. We don't really use the column number. I don't really find that super useful, but so what this particular custom like linter does is goes through all the lines and just make sure that you don't have print. And then also we double check that you don't have pretty print as well. So like you're not using either of those. And then we can run flake8 and we can point it at like our custom rules and you can get an error. So like I have flake8 set up as part of the build in Kraken, and I also have it set up locally. So whenever I check in code, it will tell me in like the commit will not work if I have a print statement, which is really useful because it turns out when you're debugging, you put a lot of print statements and you don't want those like actually checked in. So we can use flake8. We can write a bunch of custom style checker or style checkers or like different things that we want. We can turn on and off different flake8 rules. So we've got the code formatted now. We've got our imports organized the way we want. We've run flake8 on it to verify that we're not doing anything very obviously wrong or that we can enforce like different patterns that we want. Another tool that's actually not all that new to the Python ecosystem, but I see it more and more is MYPY, which is a static type checker. So you can, again, kind of analogous to thinking about it as like a compiler back in the old days, but again, it doesn't do any like compilation actually, but it will tell you whether you're like mixing types. And especially on a project as large as Kraken with over 1 million lines of Python, the typing is actually really useful to have because you might open up some code that you've never seen before and have no idea what type of variable is. So MyPy only works if you add type annotations to your code. So if we go back a little bit, notice that I did add these type annotations. So I'm annotating that I'm returning an iterable, a for tuple, and these are the types of things that are in the tuple. So I personally, it's taken me a long time to get used to this. I find that the syntax of the type annotations it just kind of like ruins a lot of the like aesthetics to me, but the benefits of them really outweigh that. Python, first off, doesn't care. So the interpreter is not going to look at these type annotations. It basically treats them as comments when you run. So if you could annotate all of your code with types and then you never run MyPy or some other kind of checker on them, basically there's no point in having them for the most part because they're just informational. They don't even have to be correct. So that's where MyPy comes in. So what you can do is you can add these type annotations and then you run MyPy over the code and MyPy will say stuff like, oh, you declared this as a string, but actually you stored an integer in there or something like that. Or this particular function claims that it takes a dictionary and you passed in a list. Another really cool thing is a lot of editors have MyPy and like static type, or not MyPy, but like static type checking built in. So like I know for example, a lot of people on our team use PyCharm. So PyCharm can look at those annotations and kind of tell you when you're hovering over a function that this particular function takes this argument or that argument and that sort of thing. So I don't have a whole lot of examples about MyPy, but what you can do is you add all these types and then you run MyPy over it and MyPy can tell you mismatch types. Another thing that we use that is maybe not as widely known, but it's actually developed by someone on that works at Octopus Energy in the UK. And it's called import linter. And what it does is it allows you to define and enforce rules for your imports. So you can think of it as like Kraken has like a very layered architecture, so that like the hierarchy and then like dependency should flow down. So you shouldn't be importing like something at the low level, like way up here. Like so, we have all these contracts, is what the import linter terminology uses, to prevent people from like importing things where they shouldn't be importing things. Like you shouldn't be. The main purpose is really to prevent this like crazy spaghetti code that you have of like imports all over the place, and like you have like something that's really high level importing from over here and then something importing back over here. So you can define these contracts in like a specific, it's like an INI file format. And then you can run import linter and it can tell you like you're violating the contract. So like here's like an example from the import linter's documentation saying that like my project.foo should never import bar or baz. And you can add your own like custom rules. So we have like a domain layer in Kraken, and then we have like a use cases layer, and like we don't want those necessarily conflicting, that sort of things like that. So import linter can like more like, it's kind of like import or enforcing like architectural patterns or like rules so that you can make sure that your code is like flowing the right way or that you're not creating a whole bunch of spaghetti code. Okay, so those are kind of the tools. And the tools are really great. I find them all very interesting, but how do we enforce usage of them? So if we just have them in our project and we don't ever enforce the usage, like what's the point? There's two different ways you can enforce the usage. You can do it locally, or you can do it on your CI system. We actually do it both ways, but we'll talk about the pros and cons of that. So the local version, the way we do it is using something called Git hooks. And this is something that's built into Git. It's not related to Python. It's not related to like linters. It's just like a thing that's built into Git. They're pretty easy to install and to create. And Git allows you to have all these like locations where you can do the hooking. So like you can do hooks right before a commit happens. You can do a hook right before a push happens, or right after a commit happens, or when a merge happens, and that sort of thing. And you can do anything you want in here. These basically just bash scripts that you can install, and then Git will, based on the name of them, Git will run them whenever that process happens. And we do all sorts of different things. So like, for example, we have a post merge, I think, hook that when you pull from GitHub, it tells you if the requirements changed and that you probably need to reinstall your requirements. So on a project as large as Kraken, the requirements.txt and stuff like that changes quite often, and it can be really easy to get out of date with something. So when you do a pull, if you install this hook that we use in Kraken, you'll get a line that prints that says, hey, actually the requirements file changed. You need to reinstall your, we could even like set that up to where it would just automatically do it, but you like probably don't want to just be like automatically updating people all the time. And then there's different various places that you can do this. One thing I want to point out is that when I say pre-commit, I'm talking about the Git hook pre-commit, not the project pre-commit. I think pre-commit project, I think it is written in Python. It kind of maybe started in the Python community, but now it supports a bunch of different languages. It's a really, really cool project for helping you like manage these types of things. So there's this whole framework for managing like pre-commit hooks across projects and across like projects that have multiple languages and stuff. But that's just to say that pre-commit is like a really cool thing to look at. But when I say pre-commit, that's not actually the project that I'm talking about. Okay, so finally, now to the like actual linting. So we've got all these tools, formatted our code, we formatted our imports, we've done some static analysis on the code and making sure maybe we don't have print statements or different things like that. We don't have any common typos and variable names. We've probably run MYPY on it to make sure that our types make sense and that we don't have anything obvious wrong there. Hopefully we've also set up import linter to kind of like enforce some of these architectural principles. How do we actually use all these things in a pre-commit hook, for example? So thinking it the pre-commit phase or the hook is, it comes down to two different things: get the files we need to lint and then actually lint them. So how do we do that? Again, a pre-commit hook is typically just a bash script, but you could do it in different ways. A simplified version of what we do is in our pre-commit hook, we run git diff -- cached to get, basically that will tell us all the files, or that's the diff of what's about to be committed. So the pre-commit hook happens right before you type like a commit message and like you start to do the actual commit process. And then we use some awk magic to just get the added and modified files. So we use the -- name status that will print like an A, M, or a D next to the file to say the file was added, modified, or deleted. We don't want to lint any files that were deleted. So all this line basically does is give us all the files that are about to be committed that were either added or modified, skip the files that were deleted. So now we have the files that we want to do, and we can do a little bit more like Unix bash magic to run all of our linters. So we use the xargs command, which is really amazing. It can do a whole bunch of different things, but the simplified thing to think about, and the main thing that it really does, is it takes a list of things, and then it will run the command that you give it for each one of those things. So this first line, we print out the list of files that we want to run, which we got from the previous step. And then we pass that into xargs and tell it to run flake8. So what this is going to do is run the flake8 command on every one of those files. And because I've talked about before how like all these tools are like good Unix citizens, like returning success and failure, we can determine whether or not something like worked or it didn't work just based on the return value. So we run flake8, and then if that succeeds, we run black with the -- check. And if that succeeds, then we run ISORT with the check only option. So this will give us an idea, like right before you're going to do all of the whole commit process, like, is flake8 happy with everything? Is black happy with everything? And then is ISORT also happy with everything? So you might be wondering, okay, but you talked about MYPY and import linter. Why did you not do those in the pre-commit hook? We don't typically use those in the pre-commit hook, mostly just for speed. MyPy on a project like Kraken that's so large is just really slow because it's doing a lot of really complicated stuff. And so an import linter is very similar. There's lots of imports to analyze. So import linter and MyPy are just pretty slow on a project that large. So it can really kind of mess up your flow. Like if we had these enabled in our pre-commit hook, you might type git commit and wait like a couple minutes before the whole process could finish. And you could type your commit message and do that sort of thing. Because just MyPy and import linter are doing a lot of like deep analysis. So there are also some downsides of Git hooks. One is the installation. Installation is not hard. Typically, it's just a symlink that you check the file into your Git, and then you create a symlink into your .git folder, and then everything works. So it's a really easy process, but the trick is that you have to have someone do it. So like if developers don't ever install the hook, even if you provided it, it's never going to work. It's never going to run. Also, Git by default provides like an escape hatch for this sort of thing. So if you run git commit -- no verify, it's not going to run your pre-commit hooks. So even if someone installed it, they can always get by it. Another downside is like if you're not really fluent in Bash, Git hooks might not be a great fit for you. You could probably use some other tools to get around that. But then, so that's the local version. And we don't have a whole lot of time to go into the like actually configuration of a CI or like your continuous integration, but we use all of our linting tools are also run on our continuous integration. We use Circle CI for that. There's a couple of benefits of doing it as a part of your CI system is it's guaranteed to run. So when our build happens, it runs Flake 8, it runs Black. There's no way to like turn that off in the build. So when you push, every build runs. Also, it's a predictable environment, meaning that every developer like sets up their own machine and they might have different settings and stuff. You could get around this problem by if you like do development in containers and that sort of thing. But the CI system, like your build is always going to run on like the same type of EC2 instance or something like that. So you get a predictable environment for running all of these things as well. So that is kind of like how we use all these linters to develop Kraken around the world, deploying to a bunch of different countries and merging hundreds of PRs a day, deploying hundreds of times a day. And we can have someone start on the team in 1 week. They can probably have their first PR merged by the end of that week because we've set up a lot of these tools to like help you like have more confidence that when your PR like actually builds and all the tests pass, all the linters are okay, like you have a pretty good confidence that your code is actually going to work. And then you can get your code deployed to a bunch of different places around the world. And we can like provide cheap, free, or not free, but cheap electricity or other things that like help decarbonize the planet. So that's all we have for today. And yeah, I'm around for any questions. And I think there's like another room that we jump into after that.
Yeah, actually, so we have questions right now. If you want to give us a couple of them live. The first one up was, do you test your code against different Python versions? And if so, how?
So Kraken, we don't actually. We run, I think we're running on Python 3.9 now, not on 3.10 yet. So we just run on that particular version. But previously, I had other jobs where I like was working on a project through this like Python 2 to 3 transition. So we would run all of our code on Python like 2.7, and then we would run all our code on like maybe, or our tests on like Python 3.4 or 3.5 at the time or something like that. The way I did that was with a project called Tox, it's TOX. So it's kind of a little similar to like a makefile or something that you set up and you tell it, okay, I want to run these commands with this interpreter, and then I want to run these commands with this other interpreter. And then as part of the build, we would tell Tox run 2.7, run 3.5, run 3.8 or something like that. So yeah, if you're testing across multiple Python versions, Tox is probably the tool you would want.
Yeah, that's the one I was going to recommend as well. There's a question from Ben about working on a project that doesn't use a formatter, but you want your personal changes to be formatted. Is there a way to just run against your code only? And I think he made a similar comment also over in the Slack channel too. So I think does everybody have to be using Black? Can I just use Black?
Yeah, it's a good question. So on our team, we do kind of require everyone to use Black because we want like all the code to look the same. But yeah, you could work on a project where maybe you only use Black. I think it would present some kind of challenges when you're using, like when you're looking at diffs and stuff though, because
yeah,
black formats the whole file. So like if you open a file that someone else edited and they didn't edit it with black, and then you ran black, it might cause a diff of like every line on the file, depending on, probably not, but like I think it would make your diffs really challenging to use. So I think, yeah, I would recommend, like if you're going to do it, like you probably need to get everyone on the project to buy in. Otherwise, like your Git history is probably going to be full of commits that are like way bigger than they actually seem, and then it gets really hard to debug, because if you look at a diff that has like 100 lines and all they did was like change white space, it can be really challenging to figure out like what actually changed.
Yeah, and Ben mentioned a tool called Darker, which sounds like it can only format code that is changed instead of the entire file. I've not tried it, but
Oh,
I'm with you. Like the whole team should be using this, should be like all on board with this, because it makes for way nicer diffs.
yeah, no, that's yeah, I'll have to look into that. That's an interesting idea. So we actually do something, I mean, it's a little tangential, but so we have like our own custom linters to verify that we do add types. So we have like custom flake8 rules to say that you have to add types to any new code. So we look at what's diffed and then only apply that particular linter to the codes that like being checked in. So like any old functions that have existed for like years, they don't have to add typing, but we do enforce typing on anything that new that is written. So that's like one of those cases where we do look at the diff and do that sort of thing. So yeah, I wonder if Darker, like I guess it just looks at the diff and probably tries to create the smallest diff possible.
Right.
So yeah, that could be really cool.
Yeah. Last question I see in there is, and maybe we all missed it, why don't you use the pre-commit project?
I think it's mostly just because we did a lot of this before pre-commit was around. We at Octopus, we have these things called spa days. So once a month, everybody stops new feature development and we just like work on things that have been bugging you in the code, or like writing some tests for something or writing some documentation and stuff. So you get one day a month to basically do like the whole janitor role.
That's
And
nice.
it's been on my list for a long time to try like setting up our stuff with pre-commit. But we have so many of these tools, it would be like a multi-day project to convert it to that. But I think it would probably be worthwhile. Yeah, there's no good reason that we don't, that I can remember. It's just that we probably did a lot of this before pre-commit was around, or like it was really mature. But
Yeah.
yeah, pre-commit is really great.
We use pre-commit over here on our projects as well and love it. It's very easy to get going with, and basically gives you no reason not to do these things, because it's just makes it all part of the natural flow of code.